Good evening, everyone. My name is Archon Fung, and I'm the acting dean of the Kennedy School. I'm extremely pleased tonight to welcome you to all to this evening's forum, Exploring Space and International Travel. This topic has captured the imagination of nearly everyone on Earth, I imagine. In the past few years, several films have weaved together recent scientific advances with fiction into compelling stories about space travel. How many people have seen The Martian? All right, more than I thought. How many people have their tickets to Star Wars opening on December 18th? You guys need to get out more. Tonight we're going to explore how far away from these types of expeditions and what types of collaboration might be necessary between now and then to make this kind of thing happen. And importantly for the Kennedy School, what kind of public leadership it will take to make this happen. Before I introduce tonight's guests, I want to offer a couple of thank yous. The first is to the Institute of Politics for making this event possible, as well as many other great conversations throughout the course of the entire year. I encourage you to check out their website to find out about upcoming events taking place right here in the JFK Junior Forum. We're extremely lucky tonight to have our two guests who will be able to discuss with us the current state and especially the future of space exploration. General Charles Bolden, to my far left, has been the administrator of NASA since 2009. He began his career in the Marine Corps, eventually becoming an aviator and then a test pilot, and then only later we learned earlier in the room, somewhat unexpectedly, an astronaut. In 1981, he became an astronaut and eventually logged more than 680 hours in 4 space flights, including the successful deployment of the Hubble Space Telescope in 1990. He was also a member of the first joint U.S.-Russian space shuttle mission with a Russian cosmonaut on the crew. General Bolden returned to the Marine Corps in 1994, rising to the rank of Major General in 1998, and served as Deputy Commander for U.S. forces in Japan and later Commanding General of the 3rd Marine Aircraft Wing. Upon retiring in 2003, General Bolden worked in the private sector for several years and then fortunately returned to public service in 2009 as NASA's 12th administrator. Dr. Mae Jemison also joins us tonight, to my left immediately. She was the first African-American woman admitted into the astronaut training program, and in 1992 she became the first African-American woman in space. Before pursuing her career at NASA, Dr. Jemison attended Stanford University and then Cornell University Medical College. She obtained her MD in 1981 and practiced as a GP. Then Dr. Jemison served as a Peace Corps medical officer in Sierra Leone and Liberia, where she taught and conducted medical research. As an astronaut, she earned the position of Science Mission Specialist, the person responsible for crew-related scientific experiments on the space shuttle. During her mission, Dr. Jemison spent more than 190 days in space. 190 days in space, using much of her time to conduct experiments on weightlessness and motion sickness. That sounds like a big sacrifice to science for me. I'd like to get to tonight's conversation rolling with a couple of general questions. First to General Bolden, the first one to General Bolden, and then a second to Dr. Jemison. First one to General Bolden, especially. You're good. And you may have thoughts on this as well. In the short, right now, I've kind of learned recently, the NASA does not actually have operational capacity for human space exploration at this very moment.
We do, but it is a U.S. capability.
A U.S. capability.
That's one of the things that we were talking about back in the back is the critical importance of the synergy between commercial space, new space, if you will, entrepreneurs, and government space. So whereas in the past, up until the end of the space shuttle program, the government was responsible for all access to space, particularly with humans. And that's where Mae and I came together in the space shuttle program. Quite correctly, President Obama followed the the decision that was made by President Bush back after we lost Columbia in 2003, that we would migrate away from the shuttle. We would fly it as long as it took to complete the International Space Station, and then we would phase out of the space shuttle program and begin to rely on industry to provide routine transportation to low Earth orbit. And that's where we are today. We now have 2 providers, Orbital, ATK, and SpaceX that carry cargo. And soon we'll have Boeing and SpaceX carrying humans to low Earth orbit, while NASA is working on the vehicles that'll get us to deep space. And Mae's going to talk a little bit about deep space, what deep space really is, because we are trying to get us to the doorstep where we can then go where Mae and her folk are hopeful that we'll go somewhere in the next century.
Very good. And so what do you think? Do you think that there is a trade-off between, on one hand, unmanned exploration, which you might think for the dollar might get you more science?
I need to do something really quickly. I really need to do something really quickly. And that is robotic exploration and human exploration. Because unless you want an all-women's crew.
Yeah.
Right?
Oh, I'm sorry.
Yeah.
I am
okay,
sorry.
We're just going to do
apologize.
that really quickly
I
so that we can get
apologize.
this in context.
I didn't even
Charlie
know.
already knew where I was going. General
Thank you.
Bolden already knew what was getting ready to
Thank
happen.
you very much.
But
right.
But may I just make one clarification too with what I think what General Bolden said is that.
Charlie, what is this?
Okay, I know I was just Charlie B.
I told him the same.
So he's my General Bolden was my first boss at NASA. When I first came into NASA, into the astronaut program, he was my first supervisor at Kennedy Space Center. But I think when you ask the question about NASA's capability for supporting human exploration, don't forget that the space station is human exploration.
Yes.
The ability to get a rocket launched and go up is one part of it, but there's major human exploration going on in the space station now. So I always like to make that clear that we don't get confused between the launch capabilities and the continued exploration.
In space, apart from the launch. Do you think that there is a trade-off between, maybe some people might think that there's more science for the dollar for robotic exploration, but maybe more spirit, more other kinds of payoff for human exploration?
Just as I mentioned before, there is no either or. We believe it's absolutely essential to have synergy between robotic and human exploration. We have been exploring Mars for 40 plus years today. We started 40 some odd years ago preparing to send humans to Mars. And, so we use robotic explorers. When we go to Mars, my belief is that the first things on the planet are going to be more robots that are going to do the construction of the facilities in which we'll live. You won't want to put a human at risk to build a habitat for a human on the surface of Mars. It's actually a waste of human time, and it's too much risk when a robot can do that today. You don't see very many cars that are being assembled by a whole bunch of people on an assembly line anymore. We've learned how to use the machine. And the discoveries that have mesmerized everybody over the last year at least, if you're talking about water flowing on Mars, views of Pluto that have just boggled the imagination, because what we've seen on Pluto, nobody expected. I don't care what, are there any planetary scientists in here? Any Pluto watchers? Did you expect anything at all that we saw? I mean, we were blown away by what New Horizons showed us when it had its closest approach to Pluto. And the lesson there is we're engaged in exploration. Exploration, by its very definition, means we don't have a clue. That's why we go. If we knew, we wouldn't be doing this stuff. And if you ever needed an example of why the critical importance of a human in this loop, it's just imagine what we could have recorded had we had humans on New Horizon instead of just the cameras and the data recorders and everything else. We still don't know a lot about it, and humans would have been able to give us a little bit more insight had they been along for the ride. So humans and robots work together. They always have, and they always will.
Collaboration. Very good. So now I want to turn to Dr. Jemison, who leads an extraordinarily ambitious and exciting project called the 100-Year Starship. And maybe you could spend a few minutes setting the stage for us about the 100-Year Starship program and how you think about its mission, its broad mission, almost certainly won't be achieved very soon, maybe not in our lifetime. So how do we think about that? But maybe before we get into that, you could tell us a little bit more about the project. For those
So in true NASA fashion, I have a couple of slides. And I want to show the slides because it's easier to talk about. Because when we talk about space exploration, we always have an idea of what we think it is, right? And we are very much influenced by the movies and things like that we see. So what we're looking with 100 Year Starship was a program that was seed funded by DARPA, the Defense Advanced Research Projects Agency, to create an organization to ensure that within the next 100 years we have the capabilities of sending humans to another star system. And what this is really about and what we're looking at, and I started with this place, Frantz Fanon said, each generation must out of relative obscurity discover its mission, fulfill it, or betray it. And the reason I bring that up is because I truly thought I would be on Mars. When I got to the astronaut, growing up as a little girl, it was no question, right? I wouldn't even have to be an astronaut, I'd just be a scientist working there. And so the issue becomes is how do we get to that mission? And I would say consider the extraordinary. So one of the pieces that we do is we look at this incremental approach, what do we do? But sometimes we need to push and things make a difference. And so when we looked at 100 Year Starship, this is the name title of our proposal, which was An Inclusive, Audacious Journey Transforms Life Here on Earth and Beyond. Because really, when you look at space exploration, it's not just about the incredible, wondrous things that we find elsewhere. What we know is that it transforms our lives, both from the perspective, and in fact, all the capabilities that are required for an interstellar journey to go beyond our solar system are the same things that are required for us to survive as a species here on Earth. The reason why I wanted to do this really quickly and use slides is just show you the scale. Because you know, when you see Star Trek, I do Star Trek instead of Star Wars, but we won't do that. But when you do see Star Trek, you know, they're zipping around and stuff like that. And we talk about Pluto. New Horizons got to Pluto really, really quickly. But here's the deal. If we look at Los Angeles and we look at New York City, we think of Los Angeles as Earth. We think of New York City as our closest neighboring star, Alpha Centauri, which is over 25 trillion miles away, 4.2 light years away. Think about Voyager, which is my marker, right, that's gone outside of our solar system. Voyager's been traveling at over 35,000 miles per hour since 1977. It's only gone 1 mile in that journey, in that long period of time. So if you were to think about how long it would take Voyager traveling at 35,000 miles per hour, it would take over 70,000 years to get to go to our closest neighboring star. So the whole game changes. This is the way we think of space exploration. I had to just show proof, right?
You were there.
So I was there. But when we think about space exploration, and this is what we all bemoan, this is what I know, but it's going to be totally different from that. This is the space shuttle, but it looks very similar to the International Space Station, right? But interstellar travel will be as different from this as, right, the bridge of the Enterprise, right? And the reason why I show that is because it's a completely different game. Here's the thing. Let's look at it another way. Put 3 grains of sand into a cathedral, and that cathedral is more filled with sand than space is with stars. It's empty. There's not a lot of things there. And it's these extreme hurdles that really drive us to do more. That's what drives us to discover the innovation, the radical leaps in these disciplines that humans need. And that's what needed for human exploration, and I'll tell you a little bit more about human exploration, the reason why humans in the equation is important, besides the fact that we're incredibly flexible, that we can see things, we can observe, we can move things and change them on the fly. Charlie can get the Hubble Space Telescope repaired, right, with humans on board that we couldn't have done robotically. There are all these things. But if you look at the challenge, it's distance. It's a long, 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 long way away, right? And you can't get there easily. There takes a lot of time. Even if we go 1/10 of light speed, it's going to take 50 years to get to our closest neighboring star. You have to be autonomous because you're not going to be able to stop off for groceries. Even if you get 5,000 people on board, you're still going to have to be autonomous. So there are all these things there. And 90% of what we're going through is called dark because we don't know what it is. Actually, we know there's something out there. But again, if we get the astronomers here, we know it's dark. And so all these things are needed. You talk about energy. Anytime you have humans on board, you have to talk about food. We have to know so much more than we know now to do this. And this is the impact. This is what's important, because it's not about going to another star system, though I desperately want to be there. I want to be a part of it. It's really about creating the capabilities, and those capabilities include learning more about the microbiome that we inhabit and grow in. If we learn about that, then we learn about how to take care of things here. We know about remote sensing and stuff like that. We have to be able to look further and deeper. Energy, you can't get there through chemical. It's going to have to be well-controlled fission, fusion, antimatter. Think about the leaps that happen just because you try this. So it's not about the journey, the actual physical journey. And in many ways, space exploration, it pushes us to do something more. So this is what the whole issue is. We believe pursuing an extraordinary tomorrow creates that better world today. And it's really about inspiring this ambition. I mean, I look back to the 60s. Okay, but it was really one of those push. We thought we could do all kinds of things. And we're living off of that feedstock right now. A lot of the miraculous things, lasers are 50 years old, but now they're just now becoming part of our world. Those are the things we're looking at. Eugene Cernan said we went to explore the moon and in fact to discover the Earth. And so what 100-Year Starship is asking, what will we discover from another star? It's those extreme hurdles. It's by trying something that we don't know how to do that impacts and transforms our life here. So that's our task. It's how do we get something that's greater, that's bigger, and that we start to look at it in a very different way. So that's my sort of blurb, first off blurb on 100-Year Starship, is what do we discover from another star by trying something that we don't really know how to do. I would say, Charlie, we know how to get to Mars. If we intended to, if we committed to, we could get to Mars. We're doing a lot of research on humans on orbit and stuff, but if we wanted to do it, we could do it. We have to have the commitment and stuff, but we don't know how to do this.
That's fascinating. Thank you very much. Good.
So that's what we're facing.
So let's spend a few minutes talking about how to get from here to there. It's going to take, as you say, commitment, but also cooperation from a lot of different kinds of folks. And so when we think about the space program of the 60s, it's all, we think about a government program. And that's kind of how I think about the space program still, even though I know that's not correct. But one of NASA's achievements and the achievements of space exploration as a human project is achieving a kind of cooperation between public and private sectors. It's not government that's doing all the work, and we know from SpaceX and many other kinds of private sector entities that they're in the mix, but certainly they're not doing all of the work. And it seems like NASA may have some lessons for other parts of the government and other parts of our human endeavor for how to have public and private cooperate toward a common goal. Can you talk a little bit about what the role is of public and private?
We're sort of the guinea pig. When you talk about involvement of commercial entities in space exploration, we are the trailblazer for national security space for the Department of Defense. You saw the Air Force, for example, go through a long process of trying to decide how they were going to certify a commercial provider to launch for them, and they finally certified SpaceX. But that was going to school on a lot of the lessons that we had learned, so that's critically important. The other thing that I think we're demonstrating is the critical importance of international collaboration and cooperation. A lot of people say, but can't we find an enemy that, that will propel us to do the kinds of things that we did back in the 60s? And my response is no, you don't need one. Mae kind of hit the nail on the head. The enemy of the human psyche is the human psyche. You've got to be able to instill in your own self the will to want to do something greater than you really are, and that's where I think NASA kind of stands out in causing people to believe that we can do impossible things. We've got a group of NASA fellows sitting here in the front that I'll. But they probably get tired of hearing me tell them that every day we turn science fiction into science fact, and we make the impossible possible. But when you stop and think about it, that's exactly what we do. Things that we do today were considered to be impossible just a few years ago. You know, but that's who we are, and that's what we do, and that's really, really, really important, I think.
That's great.
And so I would add to that whole piece about the public-private partnerships and the kind of work that happens. So frequently now, so I'm sitting back, I'm not with NASA anymore, I sort of hang around from time to time, hear things, but you so many times hear people say, well, NASA's not doing anything creative, it's all SpaceX, it's all, you know, Blue Origin, there are all these things. But the reality is they're building off of things that we already know how to do. We know how to get the low Earth orbit so it can be perfected, right? We already know those things. And part of the role of government is really doing that kind of extraordinary work that others won't invest in. And you see it not only in space, you see it in basic research, whether it's in biology, right, when you're getting down to trying to understand how pieces work. That's sort of the nano technology and all of that nanobiotech stuff really started with government labs and the push in because there's not enough money or correct funding yet in order to be able to do that basic research. So the question we have to always ask is how do we keep our government officials and policymakers and budget folks understanding that you need to invest in really big ideas and things that you don't know are going to have a payoff. And that's a problem that we're having. Sometimes people are looking at it as though, well, what do we do in 5 years? How can you tell me this is going to pay off? And we really have to push beyond that. I think folks want NASA to do stuff big. I think, so this is my thing, I think, you know, if we said, here we go, if we were going to build a moon base in 5 years, that has the kind of excitement that going to the moon in 20 years doesn't have since we did it in 10 years the first time, right? But it's really establishing, we did. Well, it's really establishing that presence which says that we're off this planet as a species that has the people signing up for a one-way trip to Mars without real clue as to what to do. It's the force that we want to be bigger than we are individually. And then we do have to reflect back how it impacts and helps people on Earth. And just really quickly, I just want to say that I grew up, I don't know if you all noticed, but my biography ended when I was at NASA, and that's been 20 years ago. And so I've done a whole bunch of other things since then and really I've been a professor, I started businesses and a whole bunch of other stuff. But here's the thing, when we start to look at what the impact of space exploration has been, it is much, much broader than, you know, the Tang and the Velcro and all of those things that people talk about, right? There is a whole field of Earth observations that has completely changed the way we look at the world. There's remote sensing that we look at. We follow animals and track things. Everybody pulls out their cell phone with their GPS on it, their materials and things. But all of that is based on stuff that happened because we tried something extraordinary. I was an African studies major in college and also engineering. And Julius Nyerere was the first president of Tanzania, was one of my favorite people. I always felt as he was very much of a hero person for me. But he said, well, they were trying to reach the moon, we were trying to reach the village, and there's this contrast that one doesn't help the other. But I would say that the reason we're able to reach the village now is because we reached the moon. And it's that ability to see beyond and to be transdisciplinary about it that really makes the difference.
Yeah, great. I want to explore a little bit the part about the public support. How do you get public support for these really ambitious, you know, kind of making the impossible happen? I think that one of the best moves the early environmental movement in Sierra Club ever made was to hire Ansel Adams to take those beautiful pictures. And now NASA provides very beautiful pictures on a regular basis, and that helps. But what are the other ways to get the broader public, which then may affect Congress and your other kinds of supporters, excited about doing these impossible things that will, I believe, as you say, yield these not only scientific advances, but very concrete advances for us here and now
in our world? The biggest thing is to lay out a plan for what you're going to do, tell people what you're going to do, and then do it. To perform. Again, in our world, if we don't perform, no one listens to anything we say. So we have a very delicate balance that we have to play. You establish a goal that's pretty grand, as grand as you think people can stomach, and then you go out and step by step you meet that. You know, Mae mentioned the fact that we went to the moon in 9 years. We did it because, you know, you had an enemy, and the objective was not to put humans on the moon. The objective was to beat the Soviets, and we did that. And then we stopped because the objective had been accomplished. Our objective is to get humans to Mars so that we can begin the exploration of the further exploration of our solar system. And President Obama said it himself in the State of the Union message that, yes, we are going to deep space. We're going to send humans to Mars, but this time we're not just doing it, you know, once and then come back home. We're going there to stay. So I think that's really important. The unfortunate thing is, and hopefully some of you in this audience will replace Barack Obama as President of the United States one of these days. You know, hopefully some few of you will decide that you want to be a member of Congress or something, because it is going to take people like you who at least have displayed an interest in this by being out here tonight, you know, to believe in it, and then to help us to sell the American public, and not just the American public, the international public, on the critical importance of what we do. Mae mentioned the village. We have a saying at NASA that we are off the Earth for the Earth. We've been living and working on the International Space Station now as an international team with, we have 20 some odd nations that collaborate every single day to make life on the International Space Station possible. We have had, I don't know how many nations who have actually had astronauts participate on the International Space Station. Any of you who have 15-year-olds that are in your family, whether they're sisters and brothers or sons and daughters or whatever, they're the space generation, because they've not lived 1 second in their life when we have not had human beings living and working on board the International Space Station. And so going back to what Mae said about people talk about human exploration of space and they think about getting there. Getting there is trivial, to be quite honest. It's what you do once you're there, and how do you take advantage of the platform that we have in low Earth orbit to get even farther. And that's what we're trying to do now. We are using the International Space Station and trying to use a commercial infrastructure that we hope we can facilitate being put in place to be the platform, the springboard for us to go on back to cislunar space first, and then eventually on to Mars, and then who knows after that. My granddaughters, I have 3 of them, and they ask me all the time, you know, they're 9 through 15. And I talk about we're sending humans to Mars, and their question to me all the time is the same. Why do we stop there? And I go, you know, give me a break. Let me at least get here. Let me do my part, you know, to get you to Mars, and then you can take us the rest of the way.
So Charlie, in the interest of this whole thing about if we can look at this a little different, I'm going to push on this, is I worry that this incremental approach is what has been damning and damaging. And because it seems like, well, you didn't really do anything that's that exciting. And I've always been quite irritated when they keep talking about the Apollo program. I was like, I was a kid then. We should be able to do something more and bigger and better than Apollo within my lifetime, right? Within my work lifetime, we should be able to do that. So I sometimes wonder that the incremental approach keeps us from moving further. In terms of getting the public commitment, and I'm going to go back to the Apollo program again. So when I was a little kid growing up, I didn't see it as a race with the Soviets. I know that geopolitically that was part of it. No, but I was smart though. And but I'm saying sort of the geopolitical aspect of it, and people talked about that. But what I remember growing up on the south side of Chicago in Woodlawn is people didn't feel like they could be a part of it. So I think what we lost is the fact that we didn't find ways to include a broad swath of people in things. What we've been trying to do with 100 Year Starship is purposefully, our first word was inclusive. So how do we get people from a range of things, whether it's physics and biology and chemistry, but art and design and storytelling, the first thing I did when I was going to apply for the grant is I sat next to the woman who was on the board of Scholastic with me, who was a marketing genius. And I said, Marianne, would you help me work on this, because we have to tell the story better. And that's the big issue. We have not told the story well enough to invite other people in. It's the same usual suspects. So what we have to do is find a way to get the folks who tell stories well, the science fiction folks, yes, they tell the story well, but marketers tell the story well. There are a lot of people can be involved in this. I'm always looked at how sort of telling, sometimes at NASA, we use the same folks all the time for different things. I can talk about the life sciences. They're brilliant. They do a really great job. But there are docs out there doing all kinds of extraordinary things. So with 100 Year Starship and our symposium is in like 2 days, that's how important this was. We have a symposium in Santa Clara, and I came here. But we have a whole cabal of life scientists who are working on things who were never involved with space exploration until they were brought in, and they were very excited about that.
I would probably beg to differ in that, you know, when you say we do, we're using the same people. The activity that's going on the International Space Station today with Scott and Mark Kelly, we have never, ever involved genomicists in anything that we've done in space. And the twin study is basically a genomic study. It is, you know, we understand mapping the human genome. We're now trying to take a look at one person who's in space, another person who's back on the planet, to see what the impact of long duration is a relative term. 1 year is not long duration yet, because we've been there for longer periods of time than that. But it is incremental. You know, I as much as I respect my dear friend Dr. Jemison, you know, we have got to sustain a program while she prepares people to do what we want to do 100 years from now. If I get people all excited and I don't have anything for them to do, I will lose them very quickly. You know, we went through, at the beginning of the Obama administration, we went through a period of saying, okay, we're going to go away from shuttle, we're going to let industry take over, and we're going to let NASA write grants. And how long do you think the space program would have survived had we done that, had we followed that tack?
But 100 Year Starship is not about what happens in 100 years from now. It's really about how do you get the capabilities, which means that you have to push now. So there's this sometimes they're discontinuous processes.
You're a doctor, Mae. You should know that the technology doesn't just happen.
No, well, I do know that, but I do know also, Charlie, that what we're talking about is so when we talk about these different pieces in the life sciences, and I can talk about the life science very strongly.
You can talk about it, that's your field.
Is because, no, it's because the people, when we look and we say we're involved in genomicists now, but those fields were going on when I was in the program there. So the issue is.
But was anybody doing anything with it?
Yeah, there were.
In space.
But that's what I'm saying.
Well, I'm talking about what is going on today.
But what I'm asking now, Charlie, let me finish this, is getting more people involved. So I was trying to get there. But getting more people involved so that we have that visibility into other fields. So we want to broadly say, okay, with the microbiome has been an issue. I learned about it in medical school, was over 30 years ago. It has been an issue. It had to be an issue in colonizing what was going on in space. We were thinking about it. But if you get more people involved, then it starts to make a difference. And so when I talk about how do we get that public commitment, it really is about getting people who don't have the ticket already, so that you give them a way. Some people call it hack space or whatever, but it gives them a way to be involved and to own it. Because I find, I'm sure you've never gone anywhere and somebody didn't find out you're an astronaut. They said, so what was it like, right? Or they wanted to find out what was going on. People are interested, they're excited, so we have to give them avenues to contribute and to participate. I use the view, so we're doing something called a virtual human crucible in Graz, Austria, in a couple weeks. But it's really about using now this perspective of if you had to be autonomous, how would you do medicine? you can't do it the same way we do it now. And so this isn't about 100 years from now. It's using it as a thought exercise to do some discontinuous work that puts us in a different perspective, and then literally try to do it.
I guess,
I gotta hang out with you guys more.
you know,
'Cause
So
despite the disagreement, what they agree on is that going to Mars is an incremental effort. And
I'm not sure.
It's a big effort.
I don't think
It's
there's
a
a
big
disagreement.
effort,
I think we're looking at the world through two different prisms.
yeah,
And we have two different missions.
We have
Yes,
two different
very
missions.
much.
My mission today is to create a successful space program for the international community. We don't do
Right here and
U.S.
now.
space.
Yeah.
That's not my job. You know, granted, I am the NASA administrator. I'm the president's principal advisor on civil space flight. But by the president's direction, my job is also to expand what we do to what we call non-traditional partners. So today, I have 700 active international agreements in everything from something as simple as crop growth or water resources management to building rocket ships. And that's with more than 120 countries.
Yeah.
That took a lot of effort. I mean, just to put the International Space Station together, it's a treaty. You know, it's not, we didn't get 5 guys together in a room and say, okay, let's go build this thing. It's a treaty, and it takes a long, long time. So what people accept as painfully incremental, and we need to do something that's boom, let's go just do it. One of the biggest things that we do, I mentioned to you, is of which I am the most proud. I think we are the foremost STEM education organization in the federal government, if not in the world. I think we dwarf what most other agencies do. Now you ask Tom Vilsack, the Secretary of Agriculture, and he'll argue with me on that, because they do an absolutely incredible job. And what we found was, we both do an incredible job, so why not join forces? And we do. We now have a collaboration with the Department of Agriculture through 4-H. 4-H reaches every single county in the United States. NASA has 50 space grant, organizations in the 50 states. Which one do I want to go to if I'm trying to reach as many kids as I can? I'm going to go do something with 4-H, and that's what we're doing right now. So, yeah, we build rocket ships and we build satellites and stuff, but the heart and soul of what we do, and I tell people every day, if my budget is $18 billion, I'm spending $18 billion a year on STEM education. And I can show you where that money's going and the products that it's bringing. Every single one of you in here, whether you're a STEM major or what, there was something in your life that came from the space program. Something inspired you to be out here tonight, and that's why most of us talk about STEAM. We realize that kids don't know that they like science and math. The
So
average
Charlie,
kid
I'm
doesn't.
gonna break in here for
Yeah.
a second, just because I just want to say, I want to counterpoint. You said your push is about running a program and your budget. So we have a very small budget, minuscule, but we want to push to get people to volunteer and be involved in other ways. So my job is actually to push Charlie, to push other folks, and to get people involved. I think that that's where we have to do. So there's this tension between what goes on and what occurs. So we can't be, if we sort of sit and say everything is fine one way, we won't get that push. We have to have that
Don't
firmament.
misunderstand me. I didn't say everything's fine.
No.
I did not. Well,
No,
but let's be very clear.
but I
if
didn't
everything
say-
was fine, we wouldn't be having this discussion.
No.
Everything is
So
not
I
fine.
think I'm hitting more buttons than I intended to.
But I just want to give fair.
But you give me fair. Let me finish my statement
I
on
just
this.
I don't want people to think that NASA is kind of sitting around.
But NASA has
waiting
a different
on things.
NASA has a different role, like you said, than what we're trying
I think
to
you'd
do.
be surprised at what we do today. Whether you're
I
talking
know
about
I know that there are
utilization
lots
of
of
social media, whether we're talking, how do we
I've
reach
got
people?
all that, but I'm trying to talk about how do we push and continue to get the public involved in the commitment, because in many times, so when you go over to Europe, a lot of times people don't see the value. They say it's really cool, but they don't want to spend any money on it. So some kind of way, things like Severe, which is an incredible program that NASA started with USAID, was using remote sensing to look at land management and other things like that. It's an incredible program, but we don't get enough visibility into it. So when people see, The public.
I disagree.
The public writ large.
No. I spend a lot of time traveling
But
to
the
a lot of
public-
countries
we have
just
to
working
tell the-
severe.
we have
We
to
just
tell the
opened a
story.
new severe
I
hub in
understand.
Bangkok, Thailand.
I know, because I talked to Gwen Artis. I'm talking about the
Okay,
public
okay,
writ large. How many people here knew that there was a severe program? that
Probably
NASA
nobody
did?
unless they're at
And
NASA.
So, unless they were NASA. So what I'm asking is, how do we tell the story better so the public writ large knows that when they do this thing that they're holding space in their hand? That's the story. That's the connection we have to make.
That's my job.
And that's
And
your.
that's
and it's
what
also,
that's what we try to do.
And it's also the job
yeah.
of people who are advocates and who are space enthusiasts to get that story out so that people feel comfortable and they don't feel like when you do something with space, it's not spending money here on Earth. And that's what I've always felt that we have to do a really, I want to go out there and want to be able to get that connectedness there. Not just the pretty pictures of space. The stars are really pretty and all of that. But there are real, tangible things that happen every day. But people pull out the cell phone and they talk about, Apple or some other company being great. And that's really cool and they are great. But a lot of that stuff came from another place. In some kind of way, it has to get the value for that.
The 100-year Starship is super successful in a shorter time frame, 5 years. What do you hope will be, say, 2 or 3 areas of major scientific or technological advance that you'll be able to point to and connect with?
So I think for us, our major first thing is changing people's perceptions about why space is important. I don't think you can do it by talking at folks. You have to do it by connecting with them and having them feel things are important. So we work with looking at putting together STEM programs that allow children, graduate students, and others to say, I'm involved with space exploration. And that's one of the ways of giving people an avenue so that we're not having to have the discussion and always trying to justify things. I think it's about science literacy as well, but we do the public symposiums as one mechanism. We're doing things we're calling crucibles, which is really about starting to look at disciplines and sort of saying, how do you leapfrog and think about something else new? The same way nanotechnology, when it was really started and people started talking about it, it was saying, let's think about something new and discontinuous. So getting people in a room and saying, can we use this perspective to look at design differently, right? One of the people who we are involved with is a professor named Carl Espelon, who does textile and design. He came to talk about how clothing would have to change if you were going to do Interstellar. So now you have to have things that are recyclable because you're not going to be able to throw them out. Some of our models now, as we're taking clothing up and we're able to clean it, we have to be able to do it less toxic. So using this perspective, what are some of the tangible things by having programs where students are involved and they understand how space is connected, volunteerism, getting enough members in so that they're willing to work on things and move stuff forward. We're really working internationally, so we're working with international organizations and trying to get that kind of volunteerism. So the issue is really one that's complementary to what, despite what we look like, but really complementary to what happens with NASA, and at the same time pushing and pulling, but they're incremental steps. And when I use the word incremental, sometimes you're talking about a little bit, there are milestones along the way. All of this doesn't happen at once. So in order to understand the microbiome, we talk about our gut, but the one in the soil is really important, right, for fixing nitrogen and all those kinds of things, which we don't know about now. So really sort of being able to get those kinds of those thought processes really going and really working hard and really thinking about it's, in fact, as a country, in fact, as a world or a nation or a species, doing bold things does not preclude us from helping today. In fact, it helps us help today.
Yes, absolutely. Okay, before I open it up, one last tiny question, and the administrator may have to take a pass on this, or not. I mean, you may have already answered it. What's your high-low for when a person's going to be on Mars?
What's my high and low?
Yeah, shortest estimate, longest estimate.
Oh, geez. I think it really all depends on commitment. It depends on the funding and things like that. The shortest estimate would be 10 years. The longest could be forever and never if we don't ever get our act together. Because we could end up dying here on this planet, by the way, if we don't figure this out.
We don't get it
because we
together.
can't figure out how to interact with one another and do other things. That's my takeaway. But the shortest would be 10 years.
10.
The longest would be
Forever.
probably 100 years from now, because we finally go down and then we figure it back out.
2030s.
2030s.
Yeah, and it's, no, that we could do it quicker, but the pathway on which we're embarked right now, the plan that we have in place, endorsed by the president, and in fact endorsed by most of Congress, not adequately funded yet. And that's why most people say, how can you do something if you don't have the funds? We have never, no visionary program ever has the funds in hand. It's like I said, you put a plan together and then you execute. And as you execute, you get more funds. And I think that's what we're doing. We are, people talk about the use of 3D printing. Well, you can talk about it all day long. We're doing 3D printing on the International Space Station today. The challenge for us right now is to stop using plastics, because we use plastics because we can feed a ribbon in. We need to be able to figure out how you contain powder so we can use a 3D printer to make components of a rocket engine that's made out of titanium or out of molybdenum or something else. And we're not there yet. So Mae's absolutely right. What we're pushing ourselves to do, we have a mission directorate that's called the Space Technology Mission Directorate. And my challenge to them is fail. Go off and try really bold things. And if they don't fail, they know that something's wrong because they're taking the easy out. Now try to get funding for, DARPA does it, but that's their job. We have a hard time in NASA explaining to people that we have a mission directorate that's going to make it possible for us to put humans on Mars in the 2030s. The James Webb Space Telescope is going to launch here in another 3 years, 2018. We spent $2 billion on James Webb before we had one component in hand, because we did not have the technology that would be able to take a telescope 1 million miles away from Earth, expose it and operate it at temperatures that are down around 40 Kelvin, which is almost absolute zero. So we had to, those materials had to be invented. And so we now have composite materials that hold the drive mechanisms for these 18 segmented mirrors that make up the James Webb Space Telescope. It took money and it took time. But we developed over and over and went back to the Congress, went back to the White House and said, we can do this. We miscalculated the first time. It's going to take us a little longer, and it's going to take us a little bit more. But we're on a solid trajectory now to fly James Webb in 2018. 2030s for humans on Mars, that is achievable. Like Mae said, it is a technological challenge, but it is perhaps more a willpower challenge than anything. I tell my international partners when we were in Jerusalem 2 weeks ago, we have 3 things that we all have to overcome, 3 hurdles. The first is politics, the second is funding, and the third is national will. And the third is the one that's so difficult. And so I'll come back to the audience again. We can't do it if you all don't get involved and get enthused. And hopefully what Mae is talking about in the 100-year Starship gets people excited about what can be done, because it's going to take people who have the will to do it. There are all kinds of things going on.
But let me do this a little bit. I need to do something a little bit. I got it, but let me do this a little bit differently. There is something that I think is really important for us to look at, which is one of the great things that it is about NASA is the transparency of a lot of its technologies and a lot of its capabilities. And what we're seeing now that is very hopeful, because if we if I'm sitting here listening, it's sort of like we're all waiting for NASA to do it, and if NASA doesn't do it, then it's not going to happen. And that doesn't have to be the case. And there's some incredible technology. So as we see cube satellites and all of those things going on, and you can do swarms of cubes, small satellites that people can manufacture quickly. I remember when I left NASA, there was a company, there was an organization, Surrey Satellite Technology in the UK, that was doing very small sats at that point in time. And I was very interested in how you could use that in developing countries because of my work with developing countries. But the fact that those technologies are there and their visibility into them, that means that the public and people who have money or crowdsourcing and other things have an opportunity, are billionaires, whatever, people putting their money together, you have an opportunity to do other things and to actually augment this work. So on the one hand, some of the really big major projects that require these extraordinary breakthroughs come out of the government, but there are also these pieces that we can take and move further along, not necessarily inside of NASA. So there's these opportunities here, and there's a really good spectrum that we can look at.
Very good. And now it's time for our questions from the audience. If people have already begun lining up, for those of you who haven't attended a forum event, a question here has 3 components. First, you have to identify yourself. The second is 1 per customer, and keep it brief. And the third is all questions end with a question mark. And so with those ground rules, let's proceed. There are 4 microphones, 1 to the left, 1 to the right, and then 1 to the left and right up on the platforms there. So yes.
Hi, my name is Peter Liu. I'm a postdoc in the physics department in engineering, and I've actually acted in the capacity of a principal investigator on more than a half-dozen spaceflight experiments on the International Space Station. So first of all, thank you very much for your time, for being here, and for all the hard work you do to keep the lights on, because it is not easy. So one of the challenges as a working scientist is that science and engineering, all these fundamental big things last longer than the attention span of a congressional election. And that seems to be the constraint. As stupid as it sounds, we have all these plans, both for our scientific experiments, and the rug often gets pulled out from under us. It's not NASA's fault, right? There's a different direction when the Congress changes party or the president changes. So you guys are talking about these things, whether it's Mars in the 2030s or, a 100-year space flight to another star system, that are going to require stability. And so we can talk about, the sort of average level of funding and how in the Apollo era it was, 4.5% of the federal budget, which would be $200 billion today instead of 18. And that's the level of resources that we spent just to get to the moon, and how we are going to get back to that point to get us to do some of these other things. But that's maybe a little bit pie in the sky. In the immediate future, what do you guys do, or how do you see getting a little bit more stability so that those of us who are planning things that are more than the next congressional election away can actually get our work done?
Well, I think when I talked before, there are 3 things that I set out to do when I became the NASA administrator. From the very first time I went to the Hill, I told them that there were 3 things I promised. That we were never going to bring them a program that wasn't reasonable, realistic. We were never going to bring them a program that was not sustainable, that we could not carry over multiple administrations and multiple Congresses, and we were never going to bring them a program that was not affordable, which means it has to fit under the flat funding curve that, that this country works with right now. Try that when you're in a development program, but we do it. And I think, again, I keep going back to performance. As we perform, we continue to get support. We have people who support commercial crew and cargo today that were death on it when we started 6 years ago. We have people who support flights to Mars today. In fact, we don't have anybody who is critical of it, to be quite honest. Everybody wants to do it. It's like Mae said, but nobody wants to fund it. So, but that is a very important first step. You go in and you're patient, and you spend time talking to the members and the staff, and you go into the public sector, and you really try to convince the public that when they go in and talk to their member, they should let them know that space exploration is important, that my son or my daughter is now interested in something that I never could get them interested in before, because they saw this damn thing called Pluto that, I hear it's a planet. I thought it was a dog. That may sound facetious, but there are now people who know that Pluto is, in fact, I call it a planet. I don't care what the other people say. But planet, dwarf, it doesn't make any difference. But to your point, there are now people talking about the work that you do as a result of our actual performance of something. The alpha magnetic spectrometer that's on the International Space Station today, unfortunately, probably 99% of people in this audience have never heard of AMS. But does that make it any less important? It is doing fundamental physics. And if we discover one antimatter particle or whatever it is, we have fundamentally changed the way we understand this world in which we live. if we go to Mars and we are able to go to where the ice flows are, and we find one living microbe in that ice flow, we have fundamentally changed everything that we know about life itself and about this universe. And that's what we're chipping away at. And you know, is it tiring? Yeah. It's fatiguing sometimes. But it's something that I think is so important to the future of humanity that we just have to stick at it. You know, I'm always bragging on the folk that are sitting here in the front, because they're the people out on the front line. I sit up in my office and I watch them work. But somebody's got to be out there doing the actual work like you all do. And Mae talked about it before. What NASA does today, we try to do, is help people understand we cannot do everything. We are not even going to try to do everything. When I go to international fora with my partners, I tell them, look, we're going to Mars. We want you to go with us. We are going to spend some time in cislunar space, and we hope that some of you who want to go down to the lunar surface will say, I will take responsibility for building a lander to get us to the lunar surface. NASA can't do that. You know, we can't do everything. So we are, in fact, trying to expand the number of people and entities that are interested in doing these things that are so essential for humanity. And I think we're doing a halfway decent job at it. You know, we just have to keep plugging away.
Thank you.
Yeah.
Over here.
Thank you. Thank you, Dean Fung. Welcome to the Harvard Kennedy School. It's great to have you here. My question,
who are you?
My name is Toma. I'm with the Kennedy School. I'm on the MPA program. I've dearly appreciated the exchange between you tonight and the openness of the exchange. This comes at odds for me with a case that we've studied 3 weeks ago at the business school, where we looked at the Columbia's final mission, and we tried to analyze how the human factor and the systemic factor have played a role into the final outcome of the mission. So my question for you, General Bolden, is what are you doing today to, what do you think about NASA's culture, and what are you doing for the culture to advance NASA's mission? And for you, Dr. Jemison, what do you think about the culture at NASA? And if you want it to be in a certain way, how would you, what would your advice be for the General Bolden?
Ladies
Thank
first.
you.
Oh my goodness. So I get to go first now,
You
huh?
get to go first.
Oh, this is a minefield. So there are two things. There are a couple things. Let's put it in context. So you have some of the most brilliant, dedicated people that you ever want to work with at NASA. So that is fundamental to really have that baseline. At the same time, you have humans at work. And so there are always, people bring with them different issues and different things. So part of the piece that we have to look at, NASA has this incredible culture where I think people want to do things, they do incredible things, they're used to doing incredible things every day. And I think Charlie will speak better about the Columbia and all of those kinds of pieces, because it's around safety and a lot of the things that he's worked on. But when I look at the culture of NASA, I have praise for it that way. I also, and this is years ago, so it may be very, very different, and I'm assuming it is under Charlie, because I worked under him and he had a very different attitude than sometimes I saw other places. But I think the big part of it is how do we continue, how would NASA continue to invite more people in to space exploration writ large? Obviously, everybody can't come in and work there, right? But how do we make sure that that happens? And I think the other part of the culture is the fact that NASA actually wants this stuff to go out. They want, you know, my experience has always been that they want to share the bounty of knowledge and possibilities and things like that. The constraints usually come from other parts of the government in terms of what can be done. And I find that that's the biggest issue. But I find the culture is very enthusiastic. But sometimes people get a little down because of all the things and the constraints that happen. And I think, again, you know, if you had people who had started working in the Apollo program when everything was there and we were going, we had really big things. And you'll see it happen, you know, for particular missions, because there are always these missions, there are always great experiments that are happening, and people get energized behind them, and we have to figure out how to transfer that enthusiasm and people so that people can see it outside of NASA as well?
If I would answer your question, it's the big thing for me is I'm the diversity champion for the agency, and hopefully everybody here will say that that's true, because I'm the person that says there are two things that are critically important for us: diversity and inclusion. And while diversity is important, which means we're going to have a disparate representation from races, creeds, cultures, all kinds of stuff, what's most important to me is inclusion, which means everybody sits at the table, and everybody sitting at the table should be heard, and they can have a disagreeing voice. That's different than the old NASA, I think. We have multiple cultures within NASA, and that's what makes us so good. There is no one NASA culture. I think the reason that we are so much better than most other organizations is that we are incredibly proud of the individual cultures. I've got, how many centers represented here? 5, 4? And if you talk to them, trust me, you'll get different dialect, you will get different cultural thought, and we like it that way. I don't want a homogeneous group in any room, because we're going to get the same old answer that we got last year from that homogeneous group that we asked the same problem. That's a guarantee for failure. But by having diverse and just diverse cultures who come together to make this one organization, I think we have been able to do the things we've done. But, social media has been critical for us, because what it has done is it has brought in literally millions of people whose voices are now a part of NASA. And when I go to a launch, and it doesn't make anytime we have an event, we generally will have what we call a NASA social. And some of you may have been. We invite people from all over the world to come. They got to get themselves there, but then we get them in. If it's a NASA center, we give them a tour, we talk about the mission and everything, and then I try to go out and talk to them, and I say, look, thanks for coming, first of all. Second thing, I want you to tell people what you feel. I don't give a crap. I don't need technical stuff from you. I got technical people. I need for you to tell people what you feel as you go through this experience. If it was the best thing you ever saw, your heart was pumping, and you started crying, say that. If you thought it was lousy, say that. But then get in touch with me and tell me what it was that we did that disappointed you. That is critical to us, and we listen. I mean, we have something called the Employee Viewpoint Survey that every organization in the federal government does. And I go over everything in the Employee Viewpoint Survey, because every single member of our workforce, 18,000 people, has an opinion. Are they respected? Do they have an opportunity to be innovative? Do they have an opportunity to speak up? It'd be great if 18,000 people all said, yeah. It doesn't happen that way. It doesn't. But we know that. But that's what we try to do to promote cultural diversity in the agency, so that we aren't the staid, afraid to speak up culture that people say existed at the time of Challenger and Columbia, as a matter of fact.
We have time for just one more question up here.
My name's John. I'm a junior at the college, and I'm hoping I might be young enough to end up moving to a Mars colony one day. We'll see. But I'm curious, if that ends up being the case, what you guys think it would be like when we get there, just in terms of things like governance. Would it be its own nation state, or just like something run by
No.
NASA or various countries
Run by
here?
NASA. Or
like,
Elon Musk.
Do you think there'll be like different colonies on Mars by different countries? Like, what exactly do you think the dynamics of that are going to end up being?
So I'm going to talk a little bit about 100-Year Starship and the kinds of things that we do, and what's happening at the symposium that happens 2 days in Santa Clara, if you all want to come for 4 days. But one of the issues is really trying to understand what are some of the ethics, what are some of the governance behavior of societies that become autonomous, that are different. Things might start off one way, but I always say, you get 10 years out and somebody says, well, you were in charge when we left Earth, but I'm not doing that now. So you really have to really understand a lot about team dynamics and things like that. How do you get the best out of people? So, you know, what we actually do is to start to look at and have experts in those areas where they get to do their own work and talk with regular people about what might happen and try to come up with different ideas. The same thing around clothing. We had these shocking ideas from, why are you wearing clothing anyway, right? There were some of the exhibitionists in the group who were saying that we don't even need to work with clothing, and then others saying, let's transform the skin into something else, you know, so that it's protective. Which there are probably a lot of folks who say that, or you look through the journals and things like that, that we're talking about those kinds of things and what we can do with humans' cells. But in terms of the governance and what it might look like, I don't really know, because right now I think a lot of the issues will be around, if you land there, can you put a claim on it, right? And those would be issues that would have to be worked out in vast treaties, and some people might say, well, I got there and you can't do anything about it. I mean, there are lots of different kinds of issues, and it will have to be worked out. So the governance, I don't know. But you invite you to start to propose different ideas, because it's only by working on those ideas, those possibilities, that we can get somewhere. And we really have to invite lots of different thought processes in. Not just when you get to the policy where you have to work out the treaty, but actually envisioning possibilities beforehand.
One of the largest growing areas of the law today is space law. And it is because there are no laws. You know, I think when Mae and I were in the astronaut office together, we flew a mission, STS-51A, and it had one task, and it was to go capture 2 lost satellites, you know, that, I mean, back to back, we launched one day, and the upper stage didn't fire, and so the owner said, okay, we'll take the risk of trying the next one the next day, because it couldn't happen twice. Well, guess what? Same failure twice, because it was the same kind of upper stage motor. And so we put together a mission to go retrieve those and bring them back. And by the way, Hughes Corporation did in fact refurbish the satellites, and they were reflown, and I think they're still on orbit today. But what came out was the conversation about, okay, but who owns them? And we went to the point that people said, well, but there is no space law, and so maritime law will prevail. And in maritime law, salvage law, the captain of the ship that goes and gets whatever they get, the booty belongs to them. And so Rick Houck, who was the commander of the mission, you know, Rick's eyes started gleaming, because he figured, okay, not really, but there was actually serious conversation about whether or not the commander of the shuttle that retrieved these 2 satellites would in fact own them. And finally, since common sense prevailed, and Lloyd's of London, the underwriter for the insurance policy, said, okay, enough is enough. We own the satellites. We paid the policy. We own the satellites. When you go get them and bring them back, then we'll make them whole and we'll do whatever else. But that was one of those real world issues. It's like Mae said, the law is constantly unfolding. I'm not sure whether you have any interest in the law, but you know, somebody's got to make those rules and regulations. The good thing is, I think, you know, realistically, we're not going to have colonies in the time that any of you are sitting here, unless something dramatically different happens. I just want to get humans continuously going to Mars, looking for evidence of life, moving robotic spacecraft out farther into the solar system, say out to Enceladus or to Europa, you know, an icy moon of Jupiter. We're looking for life. We're trying to determine the fact that we're not alone in this universe. Some places we can send people right away, other places we can't. And that's the critical importance of using robots until you have the capability of sending people. And as Mae said before, relying on government to do that until the technologies are developed, the capabilities are developed, and then you turn it over to the commercial entities. NASA has no business in low Earth orbit, and we don't do that. You know, we don't provide transportation to low Earth orbit. We rely on commercial entities. There will be a time very soon, I hope, within the next, who knows, 10, 15 years, when governments will no longer run an international space station. There will be multiple space stations in multiple orbits, because every orbit, you know, everything that we want to do, materials processing, pharmaceuticals, development, Earth observation, everything is not optimal in a 52-degree orbit or whatever it is, you know. So there will be a lot of things that will come along, and they'll come along a lot quicker than you think as other people outside of NASA and outside of government realize that we can do this. That's the biggest hurdle for them to get over. We can do this, and it's worth the investment.
Let me just add one piece. The difference between where we're going somewhere is I also believe that there are discontinuities in leaps in technological development, that those things, it may seem like they were never going to happen, like Charlie said, unless something extraordinary happens. I believe in discontinuities, and I think one of the things that we're having to reach now is that discontinuity where we have these commitments and that they can come from lots of different places. Government does some things. When we start to look at what goes on in Earth orbit, so NASA may not be the anchor tenant anymore or the one buying it, but still in terms of the kinds of research that could be done on Earth orbit, there's still that role of what government can do with technologies and materials. So it really is a continuum, and then there are these discontinuities, and what I'm hoping we can do at some time is really propel those radical leaps so that once I go into suspended animation and hibernation, that when you wake me up without my head being cut off full body, that I'm able to go on the next Starship.
That's excellent. Thank you. Thank you very much. So I was really excited about this event, and all forum events are wonderful, but I was particularly excited about this one. I think it's only now that I understand why, and it's because that space exploration is the crucible in which science and politics and policy really come together and display the best of human achievement and wonder, and I don't think I got that before this conversation, so thank you very much. I really want to thank our guests, Administrator Charles Bolden and Dr. Mae Jemison, for making the time to visit us today. Thank you for your participation and your great questions. Have a wonderful evening. Thank you.